Hello, everyone, and thank you very much for joining us today at this TAF session on AI applications. My name is Ahmad Fatahi. I'm a director of data science.
I'm Athir Al-Attar. I'm a lead data scientist.
Hello, I'm Jin Chuan. I'm also the lead data scientist.
Hello, my name is Danielle Topolsky, and I'm a lead solution engineer.
So before we start the actual presentation, the usual boilerplate disclaimer that everything we are going to talk about today are specific to this topic, and all official product communication and timelines and features will come through the official channels. Now let's talk about the actual topic of the day, and let's start by why do we even care what AI applications are and why they matter. The past couple years, before the end of the pandemic, there was a unprecedented era of expansion. But right after that, the macro climate in the economy has changed dramatically, and now everybody calls this era the era of efficiency for multiple businesses and verticals and industries. And there's a huge pressure to use technology and data and AI to make things more efficiently and faster and better and less, error prone. On the left-hand side of the chart on the bottom of the slide, you see the Spotfire ecosystem, the platform with the Spotfire itself at the center, the streaming, the data science components on the right-hand side and left-hand side of it, the connections to the enterprise data on the bottom. On the right-hand side, you see the actual real-world problems that eventually you care about. We all care about, solving energy problems or financial problems or cybersecurity or the real world happens there. The big challenge that we're going to focus today, and actually is a big focus for the whole Spotfire and our whole team here, is that plus sign, to bring the real world problem into Spotfire, or bring Spotfire technology and data to the real world problem, marry them together and see how the actual data can and the technology can help eventually make a dent in the real world. We have been investing quite a bit in that, and that's one of our big differentiators in Spotfire, to help businesses actually take value out of their data and technology. And I hope by the end of this presentation, you'll see how much we have invested in these real world problems and the verticals. We have picked a few examples from left to right: the energy sector, the health and hospital management sector, and the bottom left is the cybersecurity in a IT environment that we are going to see today. And I left the bottom right example there as another AI application that we are not going to talk about, as a teaser for you, as a hook to hopefully you're enticed enough by the end to go check out our Spotfire demo gallery. Toward the end, I'll talk about some specific references that you can check these out. Without further ado, I'd like to pass it over to our first presenter, Athir, who is going to talk about the oil well completions.
Thanks, Ahmad. So today we will talk about one of our use cases that we worked on with one of our partners, Rivet, which is basically analyzing the well completion data. Here is the agenda of the use case, and then we will see a live demo for the actual application. This is the main landing page of the application, and it's designed in collaboration with the field engineers to reflect the daily activities. The overview page gives you a quick glance for all the operations. It also lists the well's KPIs, the fuel consumption of the job, the carbon footprint, and also it gives you a comparison view for all the stages across all the wells. It also gives you some predefined goals to see how you are doing in terms of consumables and also time utilization. Everything is interactive here, and it's connected to multiple data sources. The second card is the treatment plot. This is one of the most important plots in the well fracturing. This chart or this dashboard is connected to a live data source that comes from the well pad through our partner, and then using typical stream-based services. We use the visualization mods here to visualize the most recent values in the 4 critical parameters during the fracturing. We also use Python scripting to perform some automatic activity detection, so we can see that the current activity is fracturing now. The wireline activity, it's also another dashboard that shows the operations historical view. If we are doing any wireline services, we use the text card mod here to present the recent values for that job. Moving on to the coil tubing dashboard, we use the timeline visualization mod here to have a view for the wellbore in terms of the depth and the activities that happened in the wellbore. So in the visualization at the bottom, we can see we have a depth reference. And in these cards, the green ones are the perforation charges that we fired at the well. And then the red ones are the bloods that we set. And then we can also see the timestamp that shows the time that a specific event happened. This visualization can easily be switched to be a time reference instead of depth reference. The pad metrics visualization shows the utilization of the equipment and the crew. So, and it's also called the time critical analysis. So in the matrix visualization, the second from the top, we can see a utilization across all the equipments. And then whenever we have a time slot that we're not using our equipment or the let's say crew, this time slot can be identified as an unproductive time. Below, we can see the most critical parameters for the consumables that we're using during the process, and that gives us the ability to identify any anomaly during the operations. And then we can also relate that with the 3 parameters below: the pressure, the flow, and then the slurry rate in case if we are looking for anomaly detection. The treatment plot here, this is a historical view for all the past operations or fracturing stages. In case if we want to go back and then take a look in time and then see how do we perform, and if there is any anomaly in the pressure profile or during the using the consumables during the fracture. The crew location tab, it's basically a tool to track all the crew activities. We can see what a specific crew is doing now, and then we also can connect to other communication tools in here. The stimulation response, in here we used the unsupervised learning to estimate the formation shut-in pressure. You can see the orange segment of the curve here is automatically identified using clustering, which is basically the fall down period. This period is very important when we plan the well production, and also helps us to adjust our fracturing pressure during the next operations. Any of these classifications can be saved back to a Postgres database, or we can manually select that and then save it as a user picked readings. Worth mentioning here that all of this has been done using Python support in Spotfire. And then talking about the stimulation response, we extended this work to use the mostly like the most industry practices, and then using the SPE research to further investigate the formation pressure. So we can see here that we start by selecting the stages from the top that we want to include in our calculation, and then moving on to the visualization on the right, the fall down period will be identified, and then we also still have time to do more cleansing here and isolate the fall down period. And then on the visual below, on the left, we can see that the curve has been divided into two segments. And then this division is basically based on one of the research paper, which we will use the methodology to estimate the pressure using two approaches, the early departure and then the late departure, which are basically the two segments of the curve. And then on the final chart on the right, we can see that we have two lines. We have the red dotted lines and then the green line. And then there are basically the pressure estimation using these two methodologies. That's the end of my presentation, and I'll pass it on to Jinchuan to talk about the hospital management system.
Thank you. So I will take over the time and talk through the hospital management AI application. So hospital management could be a complex problem due to the large amount of patient data and the diverse management processes. We collected the use cases from our real customers to enable them to analyze those large amount of historical data and train the machine learning models with our tools. So I will walk through the real demos. We developed 4 different parts in this dashboard. So we provide examples of analyzing the historical patient's data as the starting point. And then we provide some methods to protect the sensitive patient information. And in the last, we will use those data to train the machine learning models to help us predict the length of stay and the readmission risk of those patients. In the first part, we will use the patient's historical risking data, which contains more than 200,000 records. We can find the details of each patient's entire journey in the dataset, starting from the administration until they got discharged. Some of the columns here, like the arrival type and the bed class, those could be the important features when we use them to train the predictive models later. And when we select a row from the historical main records table, we may find that this patient has multiple visiting records in the past. So this patient journey chart can help us draw out all the important timestamps. And on the top, we have created 2 KPI metrics about waiting time from the admit to triage and from the triage to consult. It is important to monitor the maximum and average waiting time as well as the trend. We can use the color gradient to show the health condition. The greener here, the healthier it is. We can also observe the trend of the number of patients registered and find the peak hour of the day. From the control panel, users can do more filtering and selection to narrow down and find the specific types of patients. Moving on to the second part, we will apply some methods to protect the sensitive patient profile data. For example, you can notice here that some of the middle characters in the string columns, such as race and patient county, have been replaced by the random number of character X. In the patient zip column, the order of the numbers has been randomized with permutation. This kind of data masking implemented with some simple Python code that we can directly create and apply in the Spotfire. The built-in Python data function allows users to install and run any Python package actually, so they can really do the advanced use case with the power of Python package. The other method we have applied here is using the k-means that generate the k-means labels to represent the private information to some extent, and then we can use the labels to do the prediction. Moreover, we have the map chart and some simple pie charts to aggregate the personal information. The third part, we can see the model training and predicting results of the advanced analytic use case for predicting the length of stay. We have trained the machine learning model on our data science platform, and we can retrain the model easily when we click the button from the dashboard here. We implement the model validation that users can compare the predicted values to the real one. And we did the feature selection based on the correlation. And we can also check the model summary to understand attributes, coefficient, p-values, and etc. In the end, we can analyze the predicted results and find more insights. For example, we check if the average predicted length of stay for different arrival types have significant differences. In the last part, we analyze the risk of readmission of patients. So readmission risk is usually defined as patients coming back to the hospital within 30 days. The higher readmission rate can definitely negatively impact the management cost. We tried both the logistic regression and the gradient boosting to build the binary classification models, which were also created from the data science platform. By clicking the buttons on the dashboard, we can retrain the models independently. Since this use case is a binary classification problem, the models can tell us the probability of the readmission for each patient. Then we can use the color to highlight the risk level. And we can use the heat map to compare the risk over different conditions. The benefits of integrating different data sets and products seamlessly are making the collaboration among different teams more efficient and also increasing the values from the connected business processes. For hospital management use cases, it is clear to see that admin users without the advanced AI-specific skills can still consume the pipelines created by the data scientists and do some self-service analytics on the interactive dashboard. So let me show and explain how we really created those machine learning models from our data science platform. We started from creating different workflows to do different stages. So usually we started from the data preparation to join multiple data tables and then clean the data and create features. After that, we can use some other workflow to do the data exploration. Then we can understand the distribution and summary statistics about those features. We can create another workflow to do the evaluation and prepare the models for prepare the features for the modeling. So for example, here in this feature generation modeling operator, you can see the correlation. And after that, we will create the modeling workflows to predict the length of stay and import the final process training dataset. You can see that the final dataset had been passed to the machine learning operator, linear regression. And then we split the data into the validation set and the test set. And then we can export any of the results as the output. And then we can show the output in the dashboard. So that's how we connect the results from the data science platform to the interactive Spotfire dashboard you saw previously. So in summary, the customized dashboard can help the hospital management admin to find more insights from the historical data and train machine learning models from the data science platform easily to predict the length of stay and the readmission risk. Now I will pass the time to Danny.
Thank you. The AI app I'll be showing today is for log anomaly detection. This is a cybersecurity use case that uses machine learning to find anomalies in computer logs. Anomaly detection plays a big role in cybersecurity by identifying the unusual patterns or behaviors that could indicate potential threats or security breaches. In the context of a cybersecurity use case, log data serves as a valuable source of information that captures various activities and events that occur within a system, such as user logins, network connections, file access information, and more. By analyzing the patterns and characteristics of log data, anomalies can be detected. And one effective approach is leveraging a long short-term memory model, or LSTM. And this model is a type of neural network that's well suited for time series data like log data. And one key takeaway with this use case is the predictive protection component. So being able to use this type of analysis to proactively prevent attacks and respond to potential cyber threats in advance. There are multiple components to this analysis, so I'll just introduce each part here on the slides, and then I'll take you to a demo. So the first is exploratory analysis. We start by using Spotfire visuals to explore the actions and events within our computer logs and understand our data. Then we build the unsupervised model. The model was written in Python, is actually embedded in Spotfire, And it's a neural network, so the model doesn't need to be told what an anomaly looks like. They're already detected automatically just by observing the patterns in the data. And this is really helpful for a use case like this because of the nature of log data. We often don't know what an anomaly looks like or how to identify them, typically using statistical measures or business rules. Next, we have visualizations to help us assess the model learning and evaluate our model. And then we can observe the results and dive deeper into potential anomalies. There's also a root cause analysis section that helps us understand why our model has flagged certain points as anomalies. And then finally, from all this information, you can take action by writing the flags back to a database or automating alerts to analysts or systems to be notified of unusual behavior. And now I'll show a demo of this application. The app has a cover page with links to each section, and let's just get started with the first page. The first page shows a descriptive analysis of our log data. So some of the visualizations here show the log frequency color coded by actions, the counts of the successes and the failures, the distribution of the failure and success actions, or failures and successes across the actions. There's also a user analysis and then the log data itself. We can use Spotfire's advanced brush linking features to drill into certain areas of interest. For example, we can also highlight a specific user's profile here, and we can already see some interesting points. In the spider chart, there are a number of failed authentication logs for this user, and an analyst can decide if that's abnormal or not. So already we can see that using visual analytics to get a sense of our data and understand what's going on has already given us some insight into potential areas of interest to look into. The next page is a continuation of the exploratory analysis, but we've included a network chart. Network analytics is great for observing relationships between variables, and this network chart is an example of a Spotfire mod. So the mods framework allows users to build custom visuals in Spotfire using JavaScript that act exactly like native visualizations, meaning they respond to filtering and brush linking like other visualizations. And this is also, you can download this network chart mod from TIBCO Exchange as well. But this chart is showing every user connected to every system. The width of the line indicates how often the connection occurs, and the node shows how many times a system has been connected to. So we can use the filters or highlight the user that we looked at from the last page. And we can also see how many different users and systems or how many different systems this has been connected to. So we can see from this user on the last page, this user is connected to many different systems with frequent connections to an unknown system. And this is something an analyst can decide if this is expected behavior or not. Next, we'll move on to the model building page. This page is really for a data scientist. So there's lots of different personas who might interact with this type of analysis, but this is where a data scientist can build, evaluate, and rerun the model. This model was written in Python, is embedded in the analysis. Spotfire has an inbuilt R and Python engine, so you can see that the code is directly embedded into the analysis file. But one big differentiator with Spotfire and using R and Python and Spotfire is you can parameterize or use global variables in your code and dynamically change them in the visual interface. And you could also execute code, just by pressing a button like we see here. Then we can use the charts to assess the model's learning and ensure our model is suitable to be making these predictions. The next page is showing the model results. Anything above the detection limit has been flagged by the model as a potential anomaly or unusual pattern in the data. You can use brush linking again to select points on the scatter plot or also outliers on the histogram to drill into points where we can, also isolate the actual logs associated with the anomaly flags. And we can use the filters to look at different slices of the results. So we were just looking as a whole, but you can also look by action, user, or host. If we filter down to just looking at the anomalies for the different actions and look into this authentication action, we can see that the actual logs that are associated with the unusual pattern of authentication. But we also would want to understand a bit more why these points were flagged as anomalies. So then we move on to the root cause analysis section. We have a variable importance plot here where you can see that the source IP and the event status are showing as influential variables in deciding that these points were potentially anomalous or unusual. We can also see in the word cloud that we're seeing a lot of authentication and failure words populated. The word cloud is doing natural language processing on the actual logs themselves. So from this point, we know that these points were highlighted by the model. We've identified that there are patterns in our logs that are indicating a failed authentication from a specific IP at a specific time. This is definitely a significant finding that would be of interest to potentially prevent an attack. And finally, from here, we would want to take actions on the logs and actually be able to use this information. So this page, the next page that we'll show, allows us to take action on this information. This page allows us to tag and add information from the selected points. And there are many different actions you can take using these tags. The first is to tag the behavior to send as additional feedback to additional models, or writing tags back to a data source. You can also configure automated alerts for analysts or security teams, or you can also form business rules from this information to take action in a system based off of the tagged information. So you can really see the power of Spotfire as an end-to-end data science tool here, from exploratory data analysis all the way to being able to take actions on our findings. And that's the end of the demonstration. Thank you.
Thank you, Danny, and thank you, Jingchuan and Atir, for these three great presentations of three AI applications from energy, health and wellness, and cybersecurity and IT verticals. Before we close, I'd like to attract and draw all your attentions to all these resources that you can check out yourself. The AI on Demand page is this collection of various pretty well-developed AI applications like these ones that we saw today, but a bunch more exist there. It's a page in our community. You can check the link for yourself. The Spotfire Demo Gallery is a much bigger collection of several tens of these applications that we have developed and invested over several years, covering multiple different verticals. And these are not just videos. You can actually run them and in your browser within Spotfire and click through and experience them. The famous Dr. Spotfire series are all about enabling all different types of users to get more value out of Spotfire, and the exchange is our way in our community to exchange assets like mods and data functions and things that you can download and use for yourself. And hopefully by the end of this presentation, you have seen how much we have invested in these AI applications and these verticals. We are all about bringing technology and data to your real world problems and provide value. We very deeply believe in that. And as challenging as they are actually quite rewarding. And we hope that we can deliver more value to you, to your actual business problems through this collaborations. And with that, I'd like to thank you again for joining us for our presentation today, and enjoy the rest of the conference.